Video 5, let's go ahead and get to it. So I've already alluded to the fact that arithmetic sequences are linear functions. However, since the inputs are restricted and we can't plug in anything we want, the graph is going to look a bit different. It's not going to be a nice pretty line. Instead of being a continuous line, it ends up being discrete, or kind of a series of dots that aren't being connected. We just plot points that end up being in a line, but they're not necessarily connected because I don't have an ordered pair at 1/2 and at 1.5 and 1.6. I've just got it at a term number 1 and term number 2 and term number 3 and so on. Okay, so this wants us to write an explicit and recursive formula for each of these. So I'm going to do the recursive first. When you look at this along the x-axis, those are your n's. That's just your term number. Along the y-axis, those are your a sub n's. So this sequence is 10, and then 15, and then 20, and then 25, and so on. It just keeps counting up. All right, so if I wanted to write a recursive formula, it's going to be a sub n equals a sub n minus 1 plus a common difference of 5, because I'm going up by 5 each time. To find the recursive formula, that was the recursive. To find the explicit, remember I've got to plug in a bit more stuff. I'm going to have something plugged in for my first term and my common difference. Well, my first term is 10. That's that first line right there. And then my common difference, we've already said, is 5. So I'm going to distribute. It does not matter that I'm distributing backwards, because multiplication is commutative. 5 times n is 5n. 5 times negative 1 is negative 5. Now I can combine these like terms. The 5n doesn't have any like terms, and 10 minus 5 is 5. So there's my explicit formula. All right, so let's look at it in a table. They didn't use a's and n's in this, but still we know that our input is an n. Our output is an a sub n. So this is term number 1, term number 2, term number 3, and so on. And term number 1 has a value of 7, term number 2 has a value of 14, and so on. So this would be a sub 1, a sub 2, a sub 3. All right, so if I'm going to write the recursive, I got to look at what's happening. I am adding 7 because 14 minus 7 is 7. 21 minus 14 is 7, so I got 7 added. So each time I'm adding 7. That means that the recursive is a sub n equals a sub n minus 1 plus 7, because on that recursive, the only thing I replace is the common difference. The explicit, again, takes a little bit more work. I need a first term and a common difference. So the first term is 7, and then the common difference is also 7. I like it when that happens. I don't know why, I just do. So I'm going to distribute, and I get 7. 7 times n is 7n. 7 times negative 1 is negative 7. Notice I did not distribute to that 7 because it was not inside the parentheses. Now I'm going to combine my like terms. 7 minus 7 is 0, so all that's left is a sub n equals 7 times n, which makes sense because if I plug in 1, 1 times 7 is 7. If I plug in 2, 2 times 7 is 14. So there is my recursive formula. All right, you guys go ahead and try a couple. We gave you one with a table and one with a graph. It does not matter that it's listed this way. These are still your term numbers. This is still your output. Let us know if you have any questions and make sure you check your answer. See you on the other side.